What if Earth once knew something and forgot? What if the moon is not a companion, but a memory? A pale echo of a world that touched us once and never returned. Wherever you are tonight, I'm glad you're here. Let the lights dim softly around you. Let the noise of the day loosen its hold. Above every roof and forest and sleeping sea, the moon drifts in patient silence, carrying a story older than bones, older than oceans, older than the first breath ever drawn beneath a sky. Tonight, let that story unfold slowly, not as a lesson, not as a fact, but as a remembering. The moon was not always there, the earth was not always whole, and somewhere in the deep corridors of time, where dust becomes stone and stone becomes silence, something immense once happened, something that changed everything. And yet, the planet rarely speaks of it. It simply turns, it simply breathes, it keeps its secrets in orbit. In the beginning there was no beginning, only dust. Not the gentle dust that settles on shelves in forgotten rooms, but the bright, restless dust of a young star exhaling. The sun, still gathering itself, burned like a thought not yet finished. Around it, grains of rock and metal drifted in widening spirals, each particle carrying the quiet intention of becoming something more. Time did not pass then. It pooled. It thickened like cooling resin. It shimmered in heat. Within that luminous haze, gravity whispered, not loudly, not urgently, just enough, a suggestion more than a command, and dust began to lean toward dust. Flecks touched, clung, turned together in widening arcs. What had been scattered began to remember shape. The early Earth was not blue. It was not calm. It was a furnace of becoming, its surface a restless ocean of molten stone. Iron sank toward its heart like a slow confession. Lighter minerals rose and floated, glowing with heat. The young planet spun quickly, days flickering past in a blur of crimson light and shadow. There were no oceans yet, no breath, no memory, only fire. And still, beyond the edges of sight, other bodies were forming. Siblings of stone and metal, some small as mountains, some vast as continents. They circled the sun in uncertain paths, pulled by invisible threads of gravity that braided and unbraided without warning. The solar system was not peaceful, it was unfinished. Worlds brushed against one another in glancing blows. Their fragments broke free, some were swallowed, some were cast outward into cold darkness. The space between planets was thick with debris, drifting shards, molten droplets, metallic rain. And in that crowded dance something larger was taking shape. Not yet named, not yet remembered. A wandering world. It formed from the same dust as Earth. It carried the same burning isotopes, the same metallic core coiling inward under pressure. It turned beneath the same young sun. But its path was not Earth's path, not at first. It moved in a nearby orbit, slow and patient, like a thought circling the edge of awareness. The Earth did not notice. The Earth was busy becoming itself. Beneath its molten surface, convection currents rolled like hidden tides of flame. Vast plumes rose and fell, folding rock into new configurations. The crust, thin and fragile, cracked and resealed. Meteors struck and vanished into glowing seas. Yet each impact was another syllable in a language of formation. The planet's rotation was swift, almost frantic. A day lasted only a few hours. The horizon spun. The sky burned copper. The sun rose and fell like a heartbeat racing toward exhaustion. And still, the wandering world drew nearer. Gravity does not shout. It leans. Across millions of years, which felt like a single inhale in cosmic time, the paths of these two young planets bent subtly toward one another. Not because of anger, and not because of design, but because mass recognizes mass. Because presence bends space like fabric beneath a stone. Their orbits began to braid. The wandering world, slightly smaller, glowed with its own internal heat. Its surface, too, was molten. Rivers of magma traced luminous veins across its face. It spun beneath a sky empty of clouds. It had no oceans, no air. Only the deep hum of radioactive decay warming its core from within. It was not an enemy. It was not a stranger. It was kin. In the silent arithmetic of gravity, the two bodies approached a threshold. Their distances shrank not in leaps, but in fractions. Each pass drew them closer. Each near alignment tugged more firmly. The sun watched, indifferent and radiant. Space held its breath. The Earth continued to spin, unaware that its future was already curving toward it like an unseen tide. Beneath its crust, metals pooled. Lighter rock floated, the core grew denser, hotter. The magnetic whispers began to stir in its depths, faint and unsteady. The wandering world felt the pull more keenly. Its orbit shifted, its path elongated. What had once been a safe distance became a narrowing corridor of inevitability. There are moments in the life of a planet when choice dissolves, when gravity writes the script, and still, it happens slowly. Millions of years of approach, of subtle deviation, of trajectories bending by degrees so small they felt like nothing at all. Time layered itself like sediment, heat radiated outward, debris continued to strike and melt and merge, but beneath it all a convergence was unfolding. The early solar system was a place of unfinished sentences. No world was yet complete. Every surface bore scars of collision. Every orbit carried instability like a hidden tremor. It was a season of shaping when the architecture of tomorrow was carved from impact. The wandering world crossed another invisible boundary. Had its orbit intersected Earth's more deeply now. Close passes stirred tidal bulges of molten rock. The surfaces of both bodies flexed under gravitational strain. Magma swelled and receded like breath held too long. Neither planet knew the word catastrophe. They only knew motion, they only knew pull. The distance between them narrowed further. What had been a faint influence became a persistent leaning. Their gravitational fields overlapped like overlapping shadows, and space itself curved more steeply between them. Somewhere in that narrowing gap the future moon was still unformed, still dust, still potential. The Earth spun faster than it ever would again. The wandering world angled inward, its path no longer stable. It was no longer circling safely beside its sibling. It was falling slowly, into a dance that would not end in separation. The sun burned on. Fragments of smaller bodies streaked past, flaring and dissolving into molten surfaces. Shockwaves rippled across magma seas. The planets moved closer still, their mutual gravity accelerating what had once seemed distant. There are collisions that shatter, and there are collisions that create. But before either can be named, there is only approach, only inevitability. The final arc had begun, though nothing yet had touched. The wandering world's orbit collapsed inward. Drawn into a spiral too tight to escape, the Earth's gravity deepened around it like a well without edges, kept space between them thin to trembling. And in that trembling a new chapter of matter waited. Not destruction, transformation, but what the planet buried, it never truly forgot. The space between worlds is not empty. It is full of quiet forces, full of invisible hands that never quite let go. Gravity is one of those hands. It does not rush. It does not hurry the story along. It simply persists, like a low note held beneath every other sound. And when two bodies grow close enough, that note becomes the only music left. The wandering world drifted nearer, and the Earth began to feel it the way deep water feels the moon long before a tide rises. A subtle lifting, a slow swell, a pressure in the molten skin. No eyes watched this. No mind named it. Yet the planet responded, because matter responds to pull the way, breath responds to sleep. The young Earth was still raw, still soft in places, like metal fresh from the forge. And its surface glowed under a sky that had not learned to be blue. Volcanic gases rose in heavy curtains, then fell back to be swallowed by fire. The crust cracked like thin ice over boiling water, rearranging itself again and again, unable to hold a single shape for long. Above it all, the sun kept shining as though nothing important could ever happen. But something important was always happening. In the early solar system, collisions were not interruptions, they were the method. They were how worlds wrote themselves into existence. Every planet carried the signature of impact the way a tree carries rings. The Earth's body, already swollen with swallowed fragments, was becoming heavier, denser, more complete. And now, another presence approached, large enough to change everything, gentle enough in its slowness to feel like fate. The wandering world moved along its narrowing path. Its own surface trembled under strain. Tidal forces stretched it, pulled it, and flexed it like clay. Its molten mantle surged, rising into bulges that faced the Earth, then sinking away as it rotated. Heat bloomed where rock was needed by gravity's pressure, as though the planet were being warmed from the outside by an unseen palm. The approach continued, not as a straight line, not as a sudden plunge, but as a series of near meetings, each one closer than the last, a slow courtship between masses, a silent convergence. And space held the tension the way fog holds a distant light. And then, the last pass came, the one that did not widen again, the one that did not release. The Earth turned beneath the wandering world, spinning fast, almost feverish. The wanderer's orbit dipped, and gravity tightened around it. It began to fall not because it chose to, but because the path of least resistance had become a path of no return. Closer, closer still, and at a distance where their gravitational fields overlapped like merging horizons, the surfaces of both worlds began to deform. The Earth's molten crust rose into enormous tides of stone, pulled upwards and toward the approaching body. The wanderer's surface mirrored the movement, bulging in response. Between them, space itself bent deeply, like fabric stretched between two weights. This was not yet impact. This was the prelude, a slow tightening, a breath pulled in, and then, at last, though the moment arrived not as a loud event but as a threshold crossed, the wandering world touched the Earth, not like a hammer striking an anvil, but like a continent meeting a continent in a sea of fire. The collision was vast beyond human language, yet in cosmic time it happened in the blink of a star. Stone met stone, metal met metal, heat met heat. For an instant, both worlds were one luminous wound. The impact did not merely break the surface, it reached down into the deep, head into mantles and cores, during layers that had only just begun to settle. Shockwaves rippled through molten rock, racing around the Earth's body like thunder trapped beneath an ocean. The planet's skin exploded outward, not into neat fragments, but into sheets of vaporized stone, into droplets of glowing magma thrown high above the horizon. The wandering world was not destroyed in a single clean moment. It was torn, folded, swallowed. Parts of it plunged into Earth's molten mantle, disappearing like memory into deep water. Other parts were flung outward, ripped free by the violence of contact and the centrifugal spin of the young planet. A fountain of matter rose into space, not smoke, not ash, something older. A bright ring of molten fragments expanding outward in a glowing arc. Rock vapor condensed into droplets. Droplets collided, merged, broke apart, merged again. The material carried the chemistry of two worlds, Earth and the Wanderer braided together, and indistinguishable in their heat. The Earth's rotation changed in that instant. The impact stole some of its speed, slowed the frantic turning, yet it also gave the planet a new kind of balance, a new distribution of mass, as though the Earth had been reweighted, corrected by the hand of collision. And above it, a halo formed, a ring of firelight, a belt of molten debris encircling the scarred Earth like a crown. Silence followed, not because there was no sound, but because sound had no place to travel. In the vacuum the violence was mute. No roar, no crack, no thunder. Only motion, only heat, only the quiet aftermath written in spinning fragments. The Earth glowed brighter than before, its surface freshly liquefied, its atmosphere thick with vaporized rock and gas. It radiated into space like a furnace door left open. The debris ring shimmered above it, each fragment still incandescent, each droplet cooling as it circled. This was not the moon yet, and this was the raw material of a future companion. Dust molten and drifting, stone unclaimed, memory scattered. The Earth turned beneath its ring, still wounded, still molten, and the ring turned with it, caught in the planet's gravity, unable to escape, unable to fall all the way back. A boundary existed now, says the distance where debris could remain aloft, where orbit could begin to hold. Within that boundary, fragments collided gently, not with the violence of impact, but with the soft persistence of drift. They clung, they gathered, they grew into larger lumps, larger bodies slowly shaping themselves under gravity's patient instruction. Time did not move forward, it settled again. Cooling began, not quickly, not neatly. The Earth's surface, still molten, began to crust over in places, thin skins forming and breaking. Above, the debris ring gradually lost its brightest glow, shifting from white-hot to red to dim ember shades like coals beneath ash. And somewhere in that dimming halo, matter began to remember how to become a world. Some truths are not lost, they are simply folded beneath silence. The ring did not rush to become anything. It lingered. Above the wounded Earth, fragments circled in widening bands, each piece carrying the warmth of collision like a fading pulse. The brightest glow softened first, then the sharper edges cooled, rounding into beads of stone suspended in darkness. What had been chaos began to slow, and not because it wished to, but because motion always yields to gravity's long patience. The Earth beneath was quieter now, though quiet in those ages still meant oceans of magma and storms of vaporized rock. The impact had remade its surface, smoothing what little crust had formed, mixing mantle with mantle, metal with metal. Deep within, heavy elements settled again toward the core, drawn inward like secrets sinking beneath the sea. Above, the ring drifted, and it stretched across the sky like a luminous scar. Each fragment moved with its own small momentum, yet none were free. They were bound by the planet's pull, caught in the curve of its gravity well. Some pieces, too close, spiraled inward and fell back, dissolving into molten plains below. Others, flung too far, escaped into the sun's wider dominion, becoming minor wanderers, faint stones lost to distance. But within a certain band and a narrow corridor where gravity balanced motion, fragments remained. They circled, they met, they touched. When two pieces of molten rock collided in that ring, the meeting was no longer violent. The first collision had spent its fury. Now the encounters were softer, cushioned by heat, guided by shared direction. Droplets merged into larger spheres. Spheres drew in smaller shards. Each union released a little warmth, a brief flare, then settled. And time gathered them. The ring thinned in places and thickened in others. Clumps emerged like knots in a river's current. Gravity, no longer divided between two separate worlds, now focused its whisper within the debris itself. Larger fragments tugged at smaller ones, small stones surrendered and joined. The process was not visible as an event. It was an accumulation, a slow remembering of shape. That within thousands of years, which in planetary language is scarcely more than a breath, a dominant mass began to rise from the ring. It was not yet round. It was not yet steel. It was a rough congregation of molten and semi-molten material, orbiting Earth in a path that glowed faintly against the dark. The Earth felt it, not as a thought, not as recognition, but as a change in balance. The tides of molten rock on Earth's surface began to respond to this growing body above. The planet bulged subtly beneath it, a mutual leaning between masses that had once been one. The new body circled close, much closer than the moon would ever be in ages to come. It filled the sky with its presence, looming vast and red, its surface still liquid in places, rivers of magma tracing its scars. It turned slowly, locked already in a dance that would bind one face toward Earth. It was born of two worlds. Its chemistry carried the signature of Earth's mantle, yet also the fingerprint of the wanderer that had vanished into collision. Isotopes of oxygen, of silicon, of arsenic, mingled without distinction. There was no clear boundary anymore between what had belonged to one world and what to another. Matter does not remember ownership, it only remembers gravity. The growing sphere continued to gather debris from the thinning ring. Each orbit swept up smaller fragments, adding them layer by layer. Impact still occurred upon its surface. But these were gentle by comparison to the first cataclysm. The heat of accretion kept much of its outer shell molten, allowing heavier materials to sink inward, lighter materials to rise. It differentiated, it organized itself. The Earth, still cooling, began to form a more stable crust. Vast magma oceans slowly thickened at the surface, though beneath them heat remained trapped and restless. Volcanic plumes pierced the forming crust like breaths from a sleeping giant. An atmosphere of steam and gas wrapped the planet, dense and opaque, hiding its surface from any distant gaze. Between the two bodies, gravity established rhythm. The new sphere's orbit smoothed. Its path became more circular, less erratic. The debris ring, once broad and luminous, dwindled as material either joined the forming satellite or fell back to Earth. Within a relatively brief cosmic span, the ring was gone. In its place, a companion remained, still molten, still glowing faintly, but whole. The Earth's rotation slowed further under the pull of this nearby mass. Days lengthened. The frantic spin of youth eased into a steadier cadence. Tidal forces, once subtle, grew stronger now that a single body concentrated the gravitational tug. The Earth's molten mantle flexed in response, bulging toward and away from its companion with each rotation. This mutual shaping was quiet but profound. Energy transferred between them, angular momentum, an invisible currency of motion. They passed gradually from Earth's spin into the Moon's orbit. The satellite drifted outward, inch by inch, though it remained close enough to dominate the sky. Above a world of fire and steam, the newborn Moon circled like a second sun at dusk. Its surface cooled unevenly. A crust formed, cracked, and reformed as internal heat escaped. Massive impacts from leftover debris pocked its face, carving basins that would one day be filled with dark basalt plains. Unlike Earth, and it lacked oceans to soften its scars, it lacked an atmosphere thick enough to erase its wounds. It would keep them. The Earth below began its own long cooling. Rain would one day fall from the steam-heavy sky. Oceans would gather in low basins. Tectonic plates would form and begin their slow drift, carrying continents like thoughts across the surface. But in these early ages, the memory of collision remained fresh in molten rock. Two worlds had touched. One had vanished into the other. And from their mingled substance, a third presence now circled, not entirely separate, not entirely the same. The Moon was not simply born, it was remembered into being. Its existence held the imprint of an event so immense that even the planet beneath it could not fully erase it. Yet Earth would try over eons, through erosion and subduction, through oceans rising and mountains falling. The surface would be rewritten countless times. The Moon would not. It would remain largely unchanged, and a fossil of that broken dawn, preserving in silent stone the record of a moment when gravity braided two destinies into one. Above the still-forming oceans of magma, it drifted outward, slowly, almost imperceptibly. A scar made luminous, a memory set in orbit. And though ages would pass and life would bloom and fade beneath its light, the origin would remain buried beneath layers of silence, folded deep within the chemistry of rock, had whispered in isotopes that carried the breath of a forgotten planet. But what drifts away does not entirely leave. It lingers, it watches, it waits. Cooling is a kind of remembering. When fire quiets, it leaves behind shape. When motion slows, it leaves behind rhythm. The young Earth, once a furnace without pause, began at last to exhale its excess heat into the dark. Not all at once, not in surrender, but gradually like a body settling after fever. The surface, as still streaked with molten rivers, formed thicker skins of crust. These skins floated upon the deeper magma, shifting, cracking, resealing. The planet's face was restless, but no longer entirely liquid. Above it the sky thickened with vapour, steam rising from fissures, gases released from rock, a dense shroud that trapped warmth close to the ground. Rain had not yet begun, but it was gathering. The Moon, closer then than it would ever be again, loomed immense in that steam-laden sky. Its orbit, though widening slowly, remained tight enough to dominate the horizon. It rose and set with measured certainty, one face always turned toward the Earth, locked in a gravitational embrace that allowed no wandering glance. Tidal forces deepened. Even in a world without oceans, tides existed. They moved through molten mantle and newly forming crust, lifting and lowering the planet's surface by subtle degrees. The Earth flexed beneath the Moon's pull like a great lung inhaling and exhaling stone. And each rotation brought a swell, then release. Energy shifted between them in quiet exchange. The Earth's spin slowed further. Hours lengthened into something more patient. The frantic rotation of youth gave way to steadier days. The Moon's presence stabilized the tilt of the Earth's axis, anchoring it against wild swings. The planet's posture in space became more constant, its seasons, though not yet meaningful, more predictable in their future arc. Balance was emerging from violence, and above the Moon's surface cooled into permanence. A crust thickened across its molten oceans, sealing in internal heat that would fade only slowly over billions of years. Massive impacts from leftover debris continued to strike it, carving enormous basins that would remain etched in its face long after Earth's own scars were erased. The difference between the two worlds began here. Earth forgot. The Moon remembered. On Earth, that convection currents beneath the crust churned like hidden tides of fire. Heavier material sank, lighter rock rose, plates began to hint at movement, though true tectonics would take time to establish their long-wandering dance. Every few million years, vast stretches of surface would be remade. consumed into the mantle, and born again. On the Moon there was no such renewal. Its smaller mass allowed heat to escape more quickly, its interior quieted. Without sufficient energy to sustain large-scale tectonics, its crust hardened into a shell that would change little from then on. Impacts left craters that endured. Lava flows cooled into dark plains that would not be overturned. It became a record, a stone archive of early chaos. The Earth's atmosphere thickened with steam as volcanic outgassing continued. Eventually, as the planet cooled further, that steam condensed. Rain began, not as gentle showers, but as relentless downpours lasting thousands of years. Water struck hot rock and hissed into vapour, only to fall again. Oceans gathered in low basins, pooling where gravity guided them. The first seas formed under the watch of a much closer moon. Tides now moved through water as well as stone. Vast bulges of ocean rose and fell beneath lunar gravity, sweeping across newly formed shores. The rhythmic pull mixed minerals, stirred chemistry, and created shallow tidal zones where complexity would one day take root. The Moon did not intend this. It simply pulled. Gravity, patient and blind, organized the planet's fluids into motion. Tidal cycles became part of Earth's breathing. Twice each rotation, water rose toward the Moon. Twice it fell back, a quiet metronome set by a memory of collision. The Earth's axial tilt, steadied by its companion, allowed climate to avoid extremes that might have erased early stability. The seasons would one day emerge within boundaries narrow enough to permit persistence. Life, when it came, would grow under this moderated scheme, all of it traced back to that broken dawn. The Moon drifted outward, centimetre by centimetre each year, as energy transferred from Earth's spin into orbital distance. The exchange was subtle but constant. The planet's days grew longer. The Moon's path widened. Separation began even as connection endured. This is how gravity loves. And it holds and releases at once. On the Moon's surface, the largest basins filled with basalt from internal eruptions, creating dark maria that would later be mistaken for seas. These plains, smooth and shadowed, contrasted with brighter highlands scarred by countless impacts. Each crater marked a memory of a stone that once wandered too close. Unlike Earth, the Moon would not erase these marks. It had no wind to soften edges, no rain to wear down rims, and no tectonic plates to swallow ancient scars. Its silence preserved them. Below, Earth's oceans deepened. Steam gave way to clearer skies. The first stable crustal plates began their slow migrations. Subduction zones formed where one slab of rock slipped beneath another, carrying surface material back into the mantle's heat. Earth's memory folded inward. Layers of rock sank, melted, reformed. The planet became a storyteller who rewrites its own chapters. Yet the Moon became a storyteller who keeps of the original draft. From the surface of those early oceans, if any gaze had existed to look upward, the Moon would have appeared enormous, filling much of the sky, its craters still fresh, its glow faintly tinted by internal warmth. It would have seemed less a distant lantern and more a looming presence, close enough to shape the tides with visible force. Over time, as it drifted farther away, its apparent size would shrink, but in those early ages, yet it dominated. The Earth had gained more than a satellite. It had gained a stabilizer, a sculptor of tides, a keeper of ancient chemistry. And though no mind yet walked its shores, the conditions for future awareness were quietly being assembled under lunar influence. Violence had softened into rhythm, chaos had cooled into orbit, and the memory of a lost world circled still, no longer wandering but bound, its substance fused with Earth's own, and its remaining fragments gathered into a single pale companion. The broken dawn had given way to a slow morning, but even mornings carry shadows from the night before, somewhere within the isotopes of lunar rock, within the deep mantle of Earth. The signature of that vanished planet remained, indistinguishable yet present, like a forgotten name carved into stone beneath layers of dust. Time moved forward, dust settled, water deepened, and the Moon continued its silent retreat, holding in its light the fossil of an encounter that shaped everything to come. But the world that touched and vanished was not entirely gone. Before it was a theory, before it was a whisper in laboratories or a pattern hidden inside isotopes, it was simply a presence moving through young sunlight. a world without a name. It formed as Earth formed, from dust drawn inward by gravity's steady persuasion. In the wide nursery of the early solar system, material did not assemble with preference, and it gathered where it could, it thickened where motion slowed. And in a neighbouring orbit not far from Earth's path, this other planet came into being. It was smaller but not small, large enough to shape its own gravity into a sphere, large enough to melt within, iron sinking to its centre like a secret finding its depth. Silicate mantle rising above, molten and luminous, its surface a shifting sea of magma beneath a sky empty of clouds. There were no oceans to mirror the sun, had no air to soften its light, only heat and stone and slow turning. It circled the sun in a path that braided near Earth's orbit, sometimes closer, sometimes farther, like two dancers unsure whether to meet. For a time, perhaps millions of years, the arrangement held. The two worlds coexisted, separated by distance that felt safe in the vastness of space, but space is not still. Orbits drift. Gravitational nudges from other forming planets, from Jupiter swelling in the outer dark, but from Venus thickening in its own fiery cradle, altered trajectories by subtle degrees. A fraction of a degree is enough. A small tilt, a slight elongation, and the geometry of the future shifts. The unnamed world felt these changes first. Its path stretched into a more elliptical arc. At its farthest point from the sun, it slowed slightly. At its nearest, it sped. Each cycle reshaped its orbit in increments too small to notice, yet too persistent to ignore. So Earth continued its own cooling below, unaware. The two worlds began to cross paths more closely, not yet colliding, but brushing gravitational fields. Each close pass stirred tidal bulges in both bodies. Molten surfaces flexed, internal heat redistributed. These encounters were like distant conversations, brief, wordless, leaving subtle marks that lingered. If planets could sense, it might have felt like recognition, shared chemistry, shared origin, at the same isotopic breath lingering in their rock. Within the unnamed world, radioactive decay warmed its interior steadily. Aluminum-26 and other short-lived isotopes released heat as they transformed, stirring convection in its mantle. Magma plumes rose and sank. Its crust thickened unevenly. Impacts from smaller debris left scars that glowed, then cooled. It was becoming itself, but becoming is fragile in a crowded sky. The gravitational pull between Earth and the unnamed world grew stronger with each near approach. Their masses leaned toward one another, bending space between them. What had once been two independent paths began to entangle. This was not sudden, it was gradual, like erosion. Each orbit altered the next. The sun burned at the centre, indifferent. Around it, planets shifted positions in a slow ballet, governed by invisible forces. The unnamed world's path intersected Earth's more deeply now. The margins for avoidance narrowed. There is a quiet tension that builds before inevitability. The unnamed world approached again, closer than before. Earth's gravity tugged more firmly, reshaping the smaller planet's orbit mid-flight. Instead of passing cleanly by, its trajectory bent inward, shaving off a little more distance. After it receded, it did not return to the same path. It came back altered. Each pass stole a little stability, and each gravitational exchange drained energy from one motion and transferred it to another. The Earth's rotation shifted subtly. The unnamed world's orbit elongated further. It was no longer merely neighbouring, it was entangled. The solar system in those days was still cluttered with debris, fragments of earlier collisions, half-formed bodies, metallic shards drifting through space. Some were drawn into the sun, others were flung outward to colder realms. And a few struck Earth or the unnamed world, adding their mass to already molten surfaces. Every impact was a reminder that survival was temporary. The unnamed world's final approach began not as a dramatic plunge, but as another pass that simply did not widen. Its orbit destabilized beyond correction, curved inward in a tightening spiral. Gravity's whisper became insistence, the distance shrank. Earth's surface responded first. The tidal forces lifted vast swells of molten rock toward the approaching mass. The unnamed world experienced the same deformation, its mantle pulled outward in a gravitational bulge facing Earth. The two worlds leaned toward one another across the narrowing void. In that leaning, something profound was already decided. Not destruction alone, not creation alone, but transformation. The unnamed world had no future beyond this encounter. Its path offered no escape velocity, and no stable orbit beyond Earth's grasp. It was drawn inward as surely as rain falls from cloud once condensation has begun. The Earth, though larger, was not immune to change. Its rotation, its axial tilt, its internal layering, all would be reshaped by what was coming. Yet there was no malice in the motion, only mass responding to mass. The unnamed world crossed the boundary where Earth's gravity dominated completely. It began to fall, accelerating with each moment. Yet friction with Earth's outer atmosphere was meaningless in those early ages. The air was too thin, too newly formed to offer resistance. There was only stone meeting stone. And when the moment arrived, it was not a shattering blow from above, but an oblique strike, a glancing collision at a sharp angle, where the unnamed world struck Earth's side rather than its centre. The angle mattered. Had it been head-on, that both might have merged into a single larger planet without flinging material outward. Had it been too shallow, the smaller world might have ricocheted away. Instead, it struck just so, an angle that tore and sheared, an angle that vaporized mantle rock and flung it into orbit. The unnamed world began to come apart in that instant. Its iron core plunged toward Earth's own, merging in fiery descent. Its mantle, lighter and molten, was ripped outward, mixing with Earth's ejected mantle in a luminous spray. The collision was a release of energy beyond imagination, yet in the silence of space it made no sound. Shockwaves travelled through molten rock, not air. Light flared brighter than the sun for a heartbeat, then dimmed into expanding clouds of incandescent debris. The unnamed world did not survive as a separate body, but it did not vanish entirely. Its substance remained, scattered fuses orbiting. And in laboratories, billions of years later, when samples of lunar rock would be examined, their isotopic signatures would whisper this truth. Oxygen ratios nearly identical to Earth's, chemical fingerprints so similar that distinction blurred, evidence that the moon was not a captured stranger, but born of shared mantle. The unnamed world had become part of Earth, and part of the moon. It had touched and vanished. Yet nothing in the cosmos truly disappears. Matter changes form. Energy redistributes. Memory folds into new structure. The wandering planet was no longer wandering. It had given itself to collision, and from its surrender, a companion rose, but the ash had not yet finished learning how to orbit. After the impact, there was no clear boundary between what had once been separate. Mantle from Earth and mantle from the vanished world mingled in a single incandescent plume. Vaporized rock rose in a shimmering arc, and expanding outward like a breath exhaled too forcefully. Droplets of molten silicate condensed from the cloud, glowing beads suspended in blackness, each one carrying within it the blended chemistry of two destinies. The iron core of the smaller world did not remain above. It descended. Drawn inward by gravity's deeper hunger, it plunged through Earth's molten layers and merged with the larger planet's own metallic heart. In that descent, energy was released again, stirring convection currents that would persist for ages. The core grew heavier, denser, more capable of generating the magnetic field that would one day shield fragile life from solar winds. Even in loss, something was given. Above, the expanding cloud began to flatten into a disk encircling Earth's equator. Angular momentum, that invisible measure of turning, shaped its spread. Material too close fell back in fiery arcs to the molten surface below. Her material too far escaped entirely, cast into new solar orbits. But within a certain distance, fragments remained captive. The disk thickened and thinned in uneven bands. Some regions were dense with colliding debris, others nearly empty. Heat radiated outward into space, cooling the outer layers while inner regions stayed incandescent. Within this swirling halo, gravity worked patiently, coaxing clumps to form. The vanished world was no longer a sphere, it was a ring. And its identity dissolved into motion. Time passed differently in those ages. Thousands of years flowed like minutes in the language of planets. Within that span, the densest portions of the disk began to gather into a single dominant mass. Smaller fragments spiraled inward toward it, captured by its growing gravity. A shape emerged, imperfect at first, jagged and uneven, rotating rapidly as it collected matter. Each new impact altered its spin slightly, but over time the chaos averaged into balance. molten surfaces smoothed under their own weight, rounding into a sphere. This was the early moon, not yet pale, not yet cool. It glowed with internal heat, its surface a restless sea of magma reflecting Earth's own fiery face. The distance between them was small, far smaller than today. The moon loomed large in Earth's sky, a second furnace suspended above oceans that had not yet formed. Their gravitational embrace deepened. Their tidal forces intensified, transferring rotational energy from Earth to the moon's orbit. Earth's day lengthened measurably, slowing from frantic hours towards something steadier. The moon drifted outward in response, gaining distance as it gained stability. This exchange would continue for billions of years. A slow widening, a gentle separation. Yet in those first ages, the closeness defined everything. The vanished world's material, now part of the moon's mantle and crust, so carried isotopic ratios nearly indistinguishable from Earth's. Oxygen-17 and oxygen-18 signatures aligned so closely that later scientists would puzzle over them, searching for differences that scarcely existed. The evidence whispered of shared origin, of thorough mixing during the collision. The two bodies had not merely struck, they had blended. On Earth, the aftermath was no less profound. The impact had reset the surface, melting vast regions and homogenizing the mantle. As this mixing erased earlier differentiation patterns, creating a more uniform chemical distribution. The planet began its cooling again from this renewed molten state, as though given a second beginning. Rain would fall eventually, crust would stabilize, but for now, fire still ruled. The moon's own evolution diverged quickly. Being smaller, it lost heat faster. Its magma ocean began to crystallize from the bottom upward. Heavier minerals sank. The lighter ones floated to form anorthositic highlands, bright regions that would later gleam in reflected sunlight. Basaltic lava would flood large impact basins, creating dark plains known as Maria. These flows would occur hundreds of millions of years after formation, when internal heat still lingered enough to drive eruptions. But eventually, volcanic activity would cease. The moon would cool into geological stillness. Earth would not. Earth's larger mass allowed it to retain heat longer. Convection currents within its mantle drove the formation of tectonic plates, slabs of lithosphere drifting atop semi-molten asthenosphere. Subduction zones carried surface material downward, recycling crust into mantle and back again through volcanism. Memory on Earth became cyclical. Memory on the moon became static. The vanished world's scars remained visible in lunar craters, in the thickness of its crust, in the asymmetry between near and far sides. So the side-facing Earth developed thinner crust and more extensive basaltic plains, shaped by tidal heating and gravitational interactions during the early formation. Even the moon's synchronous rotation, showing one face perpetually to Earth, was a consequence of tidal locking over time. Gravitational forces gradually slowed its spin until one rotation matched one orbit. The moon learned to present a single face as though holding a permanent gaze, a reminder. The Earth and moon settled into rhythm. Their barycenter, the shared center of mass around which both orbit, lay within Earth's body, yet offset from its core. Together they circled this invisible point while orbiting the sun, a subtle wobble marking their partnership. Without the moon, Earth's axial tilt might have wandered chaotically over millions of years, driven by gravitational perturbations from other planets, with the moon's stabilizing presence. The tilt remained within a relatively narrow range. Climate patterns gained continuity. Extremes were moderated. The vanished world had given Earth more than debris, it had given steadiness. In the vast arithmetic of celestial mechanics, such outcomes are not planned. They emerge from initial conditions, from angles and velocities and masses interacting without foresight. Yet the result feels almost intentional. From destruction came balance, from obliteration came orbit. The unnamed planet no longer existed as a separate entity. Its iron heart beat within Earth's core. Its mantle circled overhead in lunar stone. Its memory persisted not as a body but as influence, shaping tides, lengthening days, stabilizing seasons. Nothing of it was wasted. The early solar system continued to settle, debris cleared, orbits smoothed. The era of frequent giant impacts waned. Planets assumed more stable paths around the sun, though smaller collisions would continue to leave their marks. The moon shone dimly at first, its glow the reflection of sunlight and the faint residual warmth of its own formation. As it cooled further, it became a mirror more than a light source, reflecting the sun's brilliance back to Earth's dark side. Night began to have a face, and that face was carved from a world that once wandered alone. In the chemistry of lunar rock, in the slowed spin of Earth's days, and in the steady tilt that allowed climates to endure, the vanished world lived on, diffused, transformed, yet essential. It had touched, it had vanished, but it had not been erased, and the ash that learned to orbit was only beginning its long, silent watch. Ash does not hurry. It drifts. It settles into quiet corners, into folds of wind, into the slow gravity of waiting. And above the cooling earth, the ash of two worlds once drifted in a ring of ember light, learning how to remain. The violence had passed. The great shearing of mantle from mantle, the plunge of iron into iron, all of it receded into the deep interior where heat continued its patient work. What lingered above was not chaos, but suspension, a wide band of molten fragments circling in a disciplined arc, neither falling nor escaping. Within that band, memory had no name. There were no borders between Earth, the vanished planet, no clean line where one ended and the other began. And every droplet of silicate carried blended signatures, oxygen ratios braided into sameness. The chemistry spoke softly of union, of thorough mixing in a moment too hot for separation. Gravity began its long correction. Fragments collided, not with fury but with inevitability. Each touch altered trajectory. Each merging reduced randomness. Larger clumps formed where density allowed. Smaller shards spiraled inward, drawn by the growing pull of mass that was quietly assembling. The process was not dramatic. It was repetitive: drift, contact, union, drift again. Time in those early epochs moved like sediment settling through water. Slow, constant, layering without announcement. Thousands of years passed as the disk thinned and thickened, as regions of higher density began to dominate. Within a narrow boundary, a distance defined by the balance between gravitational pull and centrifugal force, matter could remain in orbit without being torn apart by tidal stresses. Inside that boundary, fragments were pulled too strongly and dissolved back into Earth. Beyond it, material could coalesce. It was there, just beyond that fragile line, that the Moon began to remember itself. Not as a continuation of the vanished world, not as a replica of Earth, but as something new, shaped by both. The largest clump grew steadily, sweeping up debris along its path. Impacts added mass and momentum, but also smoothed irregularities. Molten surfaces flowed under their own gravity, rounding sharp edges into curves. Internal heat redistributed heavier materials inward, lighter materials outward. A sphere emerged from ash, still glowing, still wounded, but whole. Below, Earth continued to cool. The surface, once a continuous ocean of magma, there now bore expanding islands of solid crust. These plates floated upon semi-molten mantle, drifting slightly, colliding and separating in motions too slow to witness but constant in their persistence. Steam condensed into rain. Rain fell upon hot stone and hissed into vapour. Rain fell again. Oceans gathered in basins carved by impact and tectonic shift. The first bodies of liquid water pooled under a sky thick with cloud. Lightning flickered within storms born of heat and condensation, etching momentary veins of light through darkness. And above these newborn waters, the Moon loomed immense. It circled close enough to stretch the oceans into towering tides. Shorelines shifted dramatically with each rotation. Water surged inward and withdrew, carving and mixing, exposing and submerging rock in steady rhythm. Tides became the Earth's new breath. The Moon's gravity shaped them, not with intention, but with presence. Its pull created bulges in ocean and mantle alike, redistributing energy between spin and orbit. Earth's days lengthened gradually as angular momentum transferred outward. The Moon's path widened incrementally, drifting away even as it remained bound. This exchange was subtle but relentless. Each year the Moon retreated a fraction of distance no eye could see. Each century Earth's rotation slowed by imperceptible degrees. Separation was written into the dance from the beginning. Yet in those early ages, closeness defined the sky, and the Moon filled a vast portion of it, a molten companion cooling in synchrony. Its surface, still partially liquid, began to crystallize from the bottom upward. Anorthosite minerals floated to form a bright crust. Beneath that crust, magma lingered in pockets, occasionally breaking through in volcanic floods. Dark basaltic plains spread across large impact basins, forming smooth regions that would one day resemble seas. These maria were scars filled with memory, frozen lava marking ancient wounds, Unlike Earth, the moon had no atmosphere to blur its edges, no rain to soften its craters, no tectonics to recycle its surface. It would keep what it received. Earth, by contrast, learned to forget. Subduction zones swallowed old crust. New crust formed at spreading ridges. Mountains rose and eroded. Oceans advanced and retreated. The surface became a palimpsest, rewritten endlessly by heat and water if the moon remained a first draft. And in laboratories far in the future, samples of lunar rock would reveal isotopic similarities to Earth so precise that alternative origins would falter. Capture theories, co-formation ideas, all would bend beneath the weight of chemical evidence. The moon's oxygen ratios matched Earth's mantle too closely to be coincidence. The ash had been shared. The vanished world's mantle had mingled thoroughly with Earth's before being cast outward. The moon was not a stranger adopted later. It was a child of collision, composed of Earth's outer layers and the memory of a lost planet fused together. Its iron core remained small compared to Earth's, a consequence of the impact's angle and energy. Much of the vanished world's core had merged with Earth's own, leaving the moon deficient in metal. This subtle imbalance would shape its magnetic history, its thermal evolution, its long quieting. In its early years, the moon may have possessed a weak magnetic field, had evidence of once molten core stirred by tidal heating. But this dynamo faded quickly as internal heat dissipated. The moon grew still. Stillness became its identity. Above oceans that churned and crust that fractured, the moon drifted outward, luminous and unchanging. Its synchronous rotation locked one face toward Earth, creating a near side marked by dark plains and a far side thicker with highlands. The asymmetry spoke of tidal forces during formation, of heat drawn unevenly across hemispheres. Even in its earliest cooling, Earth's gravity sculpted the moon's internal structure. Ash had learned to orbit, and in orbit, it learned to endure. The vanished world no longer wandered through sunlight. Its substance was fixed in this pale sphere, bound to Earth in a gravitational conversation that would continue for billions of years. Nothing in the cosmos remains untouched by gravity's whisper, and nothing that touches deeply is ever entirely lost. But the quiet sculptor of tides had only begun its work. The moon did not speak. It did not announce its arrival with thunder or flame once the early heat had faded. It simply remained, suspended above a planet still learning the shape of water. In those first long ages after formation, Earth's oceans were restless. The surface of the planet had cooled enough to hold vast bodies of liquid, yet beneath that cooling crust, a heat moved in deep currents. Hydrothermal vents opened along the ocean floor, exhaling mineral-rich plumes into dark water. Continents had not yet gathered, as they would one day. The crust was thinner, more fragmented, islands of rock rising and sinking in cycles too slow for any witness. Above these shifting waters the moon pulled. Tides rose higher than any that would come later. The moon's nearness magnified its influence, lifting oceans into swelling arcs that reached far inland before retreating again. Shorelines were not fixed boundaries, but breathing margins, advancing and withdrawing in patient rhythm. Water remembers gravity. Each surge mixed minerals, carried sediments, dissolved rock into solution. Tidal pools formed in low basins, filling and emptying with steady persistence. In these shallow zones, chemistry deepened its complexity. Molecules gathered, broke apart, gathered again. Heat from the sun met minerals from sun, and between them patterns began to whisper. The moon did not know this. It simply orbited, yet its presence shaped the cadence of Earth's surface. Days were shorter then, perhaps only 5 or 6 hours long, and tides came frequently. The constant motion stirred the oceans, preventing stagnation, encouraging exchange between depths and shallows. Time layered itself quietly. On the moon's surface, Theia had bombardment conceived during what would later be called the Late Heavy Bombardment. Asteroids and comets, remnants of early planetary formation, struck both Earth and Moon with regular violence. On Earth, many of these scars were erased by tectonics and erosion. On the Moon they remained. Large basins such as Imbrium and Serenitatis formed under colossal impacts, their rims rising in jagged rings. Molten rock welled up to fill them, creating smooth plains that contrasted with the brighter and older highlands. Each crater was a fossil of motion, a memory of something that once wandered too near. The Moon became an archive of the solar system's turbulence. Its lack of atmosphere preserved even small craters in crisp detail. Micrometeorites peppered its surface over eons, grinding rock into fine regolith, a powdery layer that blanketed ancient scars without erasing them. Stillness deepened. Internal heat dissipated further. Volcanic activity waned. The moon's magnetic field, and if it once flickered, faded into absence. Without tectonics to recycle crust, its surface became a time capsule, holding within it a record of impacts spanning billions of years. Earth changed more quickly. Plate tectonics organized into a coherent system. Continents began to form from lighter granitic crust, rising above basaltic ocean floors. Supercontinents assembled and broke apart in cycles lasting hundreds of millions of years. Mountain ranges rose where plates collided, and only to erode into sediment and sink again into subduction zones. Memory folded inward on Earth. What happened at the surface was rarely permanent, but above it all, the moon endured, drifting outward at a steady rate of a few centimeters each year. Laser measurements in the distant future would confirm this gradual retreat, a consequence of tidal friction transferring energy from Earth's rotation to the moon's orbit. The widening was slow, almost tender. Earth's days lengthened accordingly, from 5 hours to 10, from 10 to 20, eventually to the 24-hour rhythm that would cradle human sleep. Each elongation marked energy passed outward, a subtle redistribution written into the mechanics of rotation. The moon became both companion and sculptor. Its gravitational pull stabilized Earth's axial tilt, preventing extreme variations that might have destabilized climate. Without this stabilizing presence, the tilt could have swung chaotically over millions of years, shifting climates violently from one extreme to another. Instead, seasons emerged within bounds. Ice ages came and went, but within a framework that allowed recovery. Life, once it arose in those early oceans, would persist through cycles of warmth and cold, guided in part by the steady tilt anchored by lunar gravity. The vanished world's gift continued quietly, in lunar samples returned billions of years later, and scientists would examine isotopic ratios of titanium and oxygen, confirming the shared origin between Earth and Moon. Computer simulations would replay the ancient collision, adjusting angles and velocities until models produced a moon, consistent with observation. The most successful scenarios would describe a glancing impact between proto-Earth and a Mars-sized body, sometimes given the name Theia, whose mantle mixed with the Earth's before forming the debris disk that became the Moon. Yet even these models would admit mystery. Questions about exact composition, about why isotopic signatures were so nearly identical, about the precise dynamics of the impact, all would remain subjects of refinement. Science would whisper, not shout. Evidence would accumulate like sediment. But long before language, long before instruments, the truth had already been written in orbit. Ash had learned to circle, and in circling it shaped the fate of oceans. The moon's steady pull influenced not only tides but also Earth's internal motion. Tidal heating within the early mantle contributed to convection patterns, subtly affecting tectonic development. The gravitational interaction acted as a long-term regulator, distributing angular momentum between bodies in a dance both mathematical and intimate. Even today, Earth's rotation continues to slow. Leap seconds are added occasionally to clocks to account for the gradual lengthening of days. These tiny adjustments are echoes of an ancient collision, reminders that the dance persists. The moon, though silent, continues to sculpt. Its phases mark time, its gravity lifts seas, its presence steadies the planet's posture. And all of it traces back to a world that once wandered near enough to be transformed. There is a melancholy in this truth, a planet lost, a companion gained. The vanished world did not survive as itself, it dissolved into union, surrendered its separate path. And yet without that surrender, the Earth would be different. Perhaps spinning faster, tilting wildly, lacking the tidal rhythms that stirred its early seas. From erasure came continuity, from collision came balance. The moon, pale and patient, carries within its stone the memory of that exchange. It does not speak of it. It does not change it. It simply reflects sunlight across the darkened half of Earth each night, a quiet reminder that even in destruction matter finds new form. And far beneath the oceans it once helped stir, fossils would one day form, remnants of life that rose under its watch, hardened into stone, folded into subduction zones, and erased from the surface. The moon would still be there, watching, drifting, holding in its silence the story of a world that touched and vanished, and of ash that learned, slowly, to orbit. But the quiet sculpture of tides has more to reveal. Long before there were creatures to measure the sea, that the sea was already listening. It listened to the pull above it, a pale body suspended in darkness, drawing water upward with a force that could not be seen, only felt. The moon did not command the oceans, it leaned toward them, and in that leaning the waters rose. At first the tides were immense. The moon circled close in those early ages, and its gravity reached deep into Earth's mantle and seas alike. Water gathered beneath it in great swelling arcs, lifting shorelines, as reshaping coasts that were themselves newly formed. When the moon moved on, the waters fell back, only to rise again with the next pass. Breath in, breath out. The Earth began to breathe in rhythm with its companion. This rhythm was not hurried. It did not seek attention. It repeated itself with patient certainty, carving patterns into stone, mixing salts into water, stirring sediments into suspension. The tides were a quiet sculptor, shaping shorelines grain by grain. And on a planet still young, these motions mattered. Shallow tidal pools formed where oceans met land. These pools filled and emptied with steady cadence, concentrating minerals, exposing surfaces to air and sun, then submerging them again. Chemistry grew more intricate in these margins, encouraged by cycles of wet and dry, heat and cool. The moon did not know this, it did not plan, but its gravity set the tempo. As Earth's rotation slowed gradually under tidal friction, days lengthened. The frenetic spin of early formation eased into steadier intervals. Each passing million years stretched daylight slightly longer, night slightly deeper. Energy lost from rotation became distance gained in orbit, and the moon drifted outward in quiet retreat. Yet even as it receded, its influence remained strong. The axial tilt of Earth, the angle at which it leaned relative to its orbit around the Sun, found stability under lunar guidance. Without this steadying mass, the tilt might have wobbled chaotically, swinging between extremes that would freeze and scorch in turn. Instead, it remained within a range that allowed seasons to cycle gently rather than violently. Summer followed winter, ice retreated, warmth returned. Life, when it emerged, would find continuity in these patterns. The moon's role was silent but profound. It was not a source of heat, nor of light beyond reflection. Its gift was balance. Its method was gravity. Beneath the oceans, her tectonic plates shifted slowly, guided by convection currents deep within Earth's mantle. The presence of the moon through tidal interactions may have influenced the vigor of these currents in subtle ways. Tidal stresses flexed the crust and upper mantle, contributing faintly to internal motion. Stone remembers pressure. Over billions of years, continents assembled into supercontinents and broke apart again. Rodinia, Pangaea, names that would come much later for cycles already underway. Their mountain ranges rose where plates collided, then eroded into sand that washed into seas. Sediments accumulated in layers, compressing into rock that held fossils of vanished worlds. Through all of it, the moon circled, its face unchanged except for the slow accumulation of micrometeorite dust. No rain softened its craters, no wind erased its basins. It remained a record of early bombardment, a fossilized surface preserving the scars of formation. The Earth forgot. The moon remembered. Yet as life took root in the oceans, first as simple single-celled organisms, the tides continued their patient work. Nutrients were cycled between depths and shallows. Coastal environments became laboratories of variation, where exposure to changing conditions encouraged adaptation. Over immense stretches of time, complexity increased. Multicellular life emerged. Plants ventured onto land. Creatures followed, breathing air that had once been volcanic exhalation, had all beneath the same lunar pull that had shaped the seas from the beginning. The moon's retreat continued, each year, a few centimeters farther, each millennium, a measurable widening. Laser reflectors placed on its surface in the distant future would confirm this steady drift. The measurement would be precise, approximately 3.8 centimeters per year, a figure that seemed small until multiplied by billions. Distance accumulates, so does time. As the moon moved outward, the tides diminished slightly in magnitude, though never entirely. The balance between gravitational pull and orbital distance adjusted gradually. Earth's days lengthened further, eventually reaching 24 hours, a rhythm that would define human life. Clocks would tick in harmony with an ancient exchange of angular momentum. Even today, tidal friction continues to slow Earth's spin. Leap seconds are inserted into atomic time to account for this subtle deceleration, a modern acknowledgement of a primordial dance. The Moon's gravitational influence extends beyond oceans. It affects Earth's precession, the slow wobble of its rotational axis over approximately 26,000 years. This wobble influences long-term climate cycles, contributing to patterns of glaciation and warming that shape ice ages, gravity writes in long sentences. The Moon's presence also affects Earth's obliquity stability over geological timescales, preventing chaotic swings that might disrupt climate systems entirely. Simulations suggest that without the Moon, Earth's axial tilt could vary wildly, perhaps between near zero and extreme angles, altering solar distribution across latitudes unpredictably. Instead, the tilt remains relatively stable, oscillating within modest bounds. Stability allows persistence. Persistence allows memory. The Moon does not shine with its own light, yet it illuminates night. It does not breathe, yet it guides tides that oxygenate oceans. It does not speak, yet it steadies a planet's posture in space. Its balance is active, its stillness shapes. In the fossil record, mass extinctions mark chapters of loss, times when life nearly erased itself under volcanic cataclysm, asteroid impact, or climatic upheaval. Yet through each extinction, the Moon remained constant overhead. Its pull continued, and its orbit persisted. Some extinctions were caused by impacts from space, stones that struck Earth with devastating force. On the Moon, such impacts are visible in stark relief. On Earth, many have been buried beneath shifting plates. The Moon is a mirror of forgotten violence. A reminder that stability coexists with fragility. The vanished world that gave birth to this companion no longer exists as a separate entity, its identity dissolved into shared mantle and lunar crust. Yet its influence continues in every tide that rises and falls, in every elongated later day. In every stable season, gravity binds the present to the past, and above the breathing oceans the quiet sculptor continues its patient work, shaping the planet not with noise but with steady pull. But the stone that remembers holds deeper fossils still. The sea does not argue with gravity, it yields. Twice each day lifts itself toward the pale companion overhead, stretching across basins, to leaning into an invisible hand. Twice it settles back as though exhaling something ancient and unspeakable. This rhythm has endured longer than mountains, longer than forests, longer than bone. The Moon does not command the waters, it simply persists. In the long Middle Ages of the planet, after fire had cooled into crust and crust into continent, the tides continued their patient shaping. Shorelines were carved and recarved, estuaries widened and narrowed. The sediment drifted along coasts in slow migration, guided by currents that traced lunar patterns. Time gathered in layers of silt. In shallow waters, reefs formed from the skeletal remains of countless small lives. Coral colonies built their limestone cathedrals under sunlight. Filtered through shifting waves, these reefs felt the pulse of tides, the slight rise and fall that exposed some edges briefly to air, strengthening resilience. The Moon's retreat was steady. Each century had its distance increased by a length too small to notice in a lifetime, yet vast when measured against geological eras. Ancient tidal patterns recorded in sedimentary rock tell of days shorter than today, of more frequent tides etched into layers of stone. Fossilized corals preserve growth rings that whisper of Earth, spinning faster beneath a closer Moon. Stone remembers rotation. The exchange of angular momentum between Earth and Moon is a quiet redistribution of motion, and as tidal bulges raised by lunar gravity lag slightly behind the direct Earth-Moon line due to Earth's rotation, gravitational interaction transfers energy outward. The bulges tug the Moon forward in its orbit, giving it momentum and causing it to drift away. In return, Earth's spin slows. This is not a theft. It is balance. The system conserves angular momentum even as individual motions change. Mathematics describes it cleanly. Reality enacts it slowly. Over billions of years, this transfer has lengthened Earth's day from perhaps 5 hours to 24, and will continue to do so long into the future. One day, far beyond the span of human concern, Earth and Moon will become tidally locked to each other. each showing the same face perpetually. But that day lies billions of years ahead, beyond the sun's own stability. For now, the dance continues. Beneath the surface of the sea, currents driven by tidal forces circulate nutrients through the depths. And upwelling zones bring mineral-rich waters towards sunlight, sustaining plankton that form the base of vast food webs. Without these circulations, oceans might stratify more severely, isolating life-supporting layers from one another. The moon's pull is woven into these systems. Even the slight flexing of Earth's crust under tidal stress influences seismic activity at subtle levels. Studies suggest correlations between tidal forces and the timing of certain small earthquakes. Though the relationship is delicate and complex, gravity presses gently on stone. In polar regions, tides beneath ice shelves contribute to the movement and cracking of glaciers. The rhythm continues, interacting with climate, with ocean currents, with the slow breath of the planet's water cycle. Throughout ice ages and warm intervals, through supercontinents forming and fracturing, the moon remained in its orbit, farther now than before, but still present enough to guide. At its surface aged quietly. Micrometeorites continued their soft rain, pulverizing rock into regolith that coated ancient highlands. Solar wind implanted particles into this dust, leaving chemical traces that would later be studied. The absence of atmosphere meant that even the smallest impacts left marks that endured. The moon became a museum of the early solar system. Craters within craters, overlapping histories frozen in place. The far side, though shielded from Earth's gaze until spacecraft revealed it, bore its own pattern of highlands and scars. The near side, visible through every age of human myth, carried dark plains that resembled seas but held only solid basalt. Human eyes would one day look upward and imagine stories in those patterns. Faces, animals, deities. The moon would become a mirror for myth long before it was a subject of geology. But long before eyes or myth, it was a stabilizer. Simulations of Earth without a large moon suggest a more chaotic axial tilt varying unpredictably over millions of years. Such variation could produce extreme climatic swings, challenging the persistence of complex ecosystems. The moon's mass dampens these variations, anchoring the tilt through gravitational torque. Stability fosters continuity, continuity fosters memory. The vanished world's mantle, now part of this pale sphere, continues to exert influence not as forceful command but as constant presence. The iron that once formed its core strengthens Earth's magnetic field, shielding atmosphere from solar stripping. The silicates that formed its outer layers reflect sunlight back toward darkened hemispheres. Even human sleep in ages far removed from collision would align with the cycle of lunar phases. The waxing and waning light became a calendar before numbers. Farmers planted by it, travellers navigated by it. The poets wrote beneath it, unaware that its origin lay in planetary violence. The moon's retreat is measurable today with laser-ranging experiments. Reflectors left by astronauts bounce beams back to Earth, confirming the steady increase in distance. Data accumulates year by year, a precise record of separation. Yet even as it drifts, the moon's influence remains woven into Earth's systems. Tidal friction continues. Precessional cycles continue. Climate oscillations unfold within bounds. That separation does not mean absence. The quiet sculptor does not require closeness to shape. Above continents that rose and eroded, above species that emerged and vanished, above civilizations that would one day bloom and fade, the moon held its orbit. It has watched 5 mass extinctions reshape life. It has witnessed continents collide and tear apart. It has illuminated nights when meteors streaked through skies, remnants of the same early chaos that formed it, and its face has remained largely unchanged for over 3 billion years. Earth's face has changed beyond recognition. If memory were measured by preservation, the moon would hold the older story. It keeps the record of bombardment that Earth's tectonics have erased. It holds in its isotopes the fingerprint of a lost world. It maintains in its orbit the legacy of a glancing blow that shaped climate, day length, and ocean rhythm. The sea still listens, the tides still rise. The moon still drifts outward, centimetre by centimetre, carrying with it the silent testimony of a world that touched and vanished. And in its lightless craters, fossils of sunlight and stone wait beneath dust older than any ocean. The moon does not erase, it keeps. Where Earth folds its history into molten depths, where mountains crumble and sink, Where oceans dissolve the edges of memory, the moon remains still. Its surface is a page that has not been turned in billions of years. Had inked with impact, written in shadow. There is no wind there, no rain to soften a rim, no river to carve a valley, only dust settling upon older dust. The light that touches it is borrowed. Sunlight reflected across a face carved long ago. In that reflected glow, craters reveal themselves like ancient scars on weatherless skin. Some overlap others, creating a layered archive of collisions. Younger craters shine brighter, their rays stretching outward in pale streaks. And older ones are softened by time, their edges rounded by the slow rain of micrometeorites. Each crater is a fossil of motion. Each basin is a memory of something that once wandered too near. On Earth, such memories are rare. The crust recycles itself through subduction and volcanism. Impact craters are buried beneath sediment, folded into mountain ranges, melted into new rock. Only a few remain visible, and even those are weathered by wind and water. The moon remembers what Earth forgot. That the great basins, Imbrium, Orientale, Serenitatis, span hundreds of kilometers, formed by impacts so immense they melted crust and reshaped hemispheres. Their rims rise like frozen waves, concentric rings marking shock waves that once rippled through solid stone. Within these basins lie dark plains. Basaltic Maria. Once molten lava flooded into the impact scars, cooling into smooth expanses darker than surrounding highlands. These plains, mistaken for seas by early observers, are silent fields of ancient pseudotomide. They record an era when the moon still possessed enough internal heat to bleed through fractures. That heat is gone now. The moon's interior has cooled into quiet. Seismic instruments left upon its surface detected faint tremors, moonquakes, some caused by tidal stresses from Earth, others by thermal contraction as day turns to night. But these tremors are gentle compared to Earth's restless tectonics. The moon's crust is thick, and especially on its far side, the near side, facing Earth, bears thinner crust and more Maria, a consequence of early tidal heating and gravitational shaping. Even in its formation, Earth sculpted the moon unevenly. Gravity leaves fingerprints. Beneath the regolith lies a nothosite crust, rich in plagioclase feldspar, minerals that floated upward in the moon's early magma ocean. This bright crust formed as heavier materials sank. It is ancient beyond measure, dating back over 4 billion years, preserving the earliest chapters of planetary differentiation. Samples returned to Earth revealed isotopic patterns that tied moon and planet together. Oxygen isotopes matched almost perfectly, an extraordinary similarity given the diversity found among other solar system bodies. The evidence spoke softly but clearly. The moon was born of Earth's mantle, mixed thoroughly with that of the vanished world. Within these stones lies the fingerprint of collision. The tiny variations in tungsten isotopes hint at core formation timelines. Ratios of titanium and chromium tell of shared origins. Even noble gases trapped in lunar rock whisper of early solar winds interacting with a surface unprotected by atmosphere. The moon became a collector of particles. Solar wind implanted hydrogen and helium into its regolith. Micrometeorites delivered carbonaceous material. The surface absorbed and preserved layer upon layer, without disturbance. Earth's atmosphere shields it from much of this constant rain. Its magnetic field deflects charged particles, its geology churns and buries, but the moon stands exposed, receiving and keeping. There is a loneliness in that exposure, yet also clarity. When astronauts first walked upon its surface, their boots pressed into dust, untouched for millions of years. The regolith held the imprint sharply, preserved in the absence of wind. Footprints remain there still, unchanged, silent. But the moon does not forget footprints. Its gravity is weak, only 1/6 that of Earth's, a reminder of its smaller mass. Escape velocity is low. Gases released from its interior drift away into space, unable to form a lasting atmosphere. Without air, there is no erosion. Without erosion, there is preservation. This preservation extends backward into deep time. Craters record the frequency of impacts during the late heavy bombardment, offering clues to the solar system's early instability. The radiometric dating of lunar samples allows scientists to construct timelines of formation and resurfacing events. Through the moon, Earth's own early history, largely erased, can be inferred. The moon is a mirror angled backward. It reflects not only sunlight but antiquity. In its lightless craters near the poles, regions remain in permanent shadow. Temperatures there are so cold that volatile compounds, including water ice, can persist for billions of years. Traces of ice have indeed been detected, delivered perhaps by comets and preserved in darkness. Even in dryness, it holds memory of water. The contrast between Earth and Moon is profound. Earth is dynamic, alive with cycles of carbon and nitrogen, oxygen and plate tectonics. Its surface changes daily, seasonally, geologically. The Moon is static, a geological fossil. Yet without the Moon's formation, Earth's path might have been less hospitable to life. The stabilizing torque, the tidal stirring, the lengthening of days, all contributed to a climate and rhythm conducive to biological complexity. The fossil in the sky helped create living fossils below, and still the Moon drifts outward. Its retreat is slow but certain, measurable yet gentle. The gravitational bond persists even as distance increases. One day, billions of years hence, solar evolution will alter the system entirely. But for now, the dance continues, in the vast silence of space. Yet the Moon keeps watch. It holds in its stone the record of a world that once wandered too near. It preserves in its orbit the consequence of that encounter. It bears scars that Earth has long since hidden. The light that touches its surface tonight is the same sunlight that once illuminated molten oceans of rock. The shadows within its craters are older than any mountain on Earth. Its regolith has felt the quiet rain of micrometeorites for eons beyond counting. It is a fossil of collision, and a memory set in stone. And beneath its stillness lies a deeper widening yet to be felt. There are places on the Moon where sunlight has never touched. Deep within certain craters near the poles, the sun's rays skim so low along the horizon that their light cannot descend into the hollow depths. These regions remain in permanent shadow, colder than most places in the solar system not hidden in distant space. Temperatures there fall so low that molecules slow to near stillness. In that cold memory lingers. Water molecules, delivered by ancient comets or released from volcanic breath long ago, drifted across the lunar surface and found refuge in these shadowed pockets. There they froze, preserved for billions of years in darkness older than oceans. Even in a place defined by dryness, traces of water endure. The Moon is full of such paradoxes. It is lifeless, yet it holds clues to life's origins. It is subatomic, yet it speaks through isotopes. It is unchanging, yet it marks the passage of time with layered craters that record epochs of bombardment. The regolith that blankets its surface is not simple dust. It is a complex mixture of shattered rock, glassy beads formed by micrometeorite impacts, and fragments fused by repeated collisions. Over eons this layer thickened, a slow snowfall of debris from space, grinding stone into finer and finer particles. Each grain has been struck and struck again, and each carries within it the history of countless impacts. On Earth, such fine records would be erased by wind and water. Here they accumulate undisturbed. The Moon's far side remained unseen from Earth for most of human history. Only when spacecraft circled beyond the horizon did its hidden face reveal itself, a landscape more heavily cratered, with fewer dark maria than the near side. The crust there is thicker, less pierced by ancient lava flows. This asymmetry traces back to formation. And during the Moon's early molten phase, tidal forces from Earth concentrated heat on the near side, thinning its crust. Lava more easily breached the surface there, filling basins with basalt. The far side cooled differently, preserving its brighter, highland-dominated terrain. Even the Moon's face remembers gravity. Within the largest impact basins, central peaks rise. Mountains formed when compressed crust rebounded after collision. These peaks expose material from deep beneath the surface. They're offering glimpses into internal composition. Through them, the stratigraphy of lunar crust can be read like pages in stone. Radiometric dating of returned samples places the Moon's formation at approximately 4.5 billion years ago, not long after the birth of the solar system itself. This age aligns with models of a giant impact during Earth's final stages of accretion. The vanished world, often called Theia in modern language, left its mark not only in lunar rock but in Earth's own core. The Moon's small iron core, proportionally much smaller than Earth's, supports this narrative. Most of Theia's metallic heart likely merged with Earth's, contributing to its density and magnetic dynamo. The Moon retained mostly mantle material, explaining its lower overall density. Matter rearranged, identity dissolved. Preserved in lunar samples are tiny isotopic anomalies that hint at the early differentiation of both bodies. Their tungsten 182 signatures provide clues to the timing of core formation. Variations in volatile element abundance reveal how intense heat during the impact drove lighter compounds into space. The Moon is depleted in volatiles compared to Earth, a consequence of its fiery birth. Water and other easily vaporized substances were largely lost during formation, though some later arrived by cometary delivery. Its dryness is part of its memory. Yet in the polar shadows, ice persists, faint, fragile, but real, a reminder that even in barrenness, traces of fluid remain. The Moon's gravitational field is uneven, marked by mass concentrations known as mascons beneath certain maria. These denser regions influence spacecraft trajectories subtly, a testament to the irregular internal structure shaped by ancient impacts and lava flows. Nothing about the Moon is random. Every crater, every pore, every anomaly in its gravitational field traces back to formation and early evolution. And through it all, Earth has continued to change. Continents drifted, collided, separated. Oxygen filled the atmosphere through the labour of photosynthetic organisms. Forests rose and fell, dinosaurs walked beneath a familiar moon. Extinction events reshaped ecosystems. Ice sheets advanced and retreated in cycles influenced partly by axial precession stabilized by lunar presence. The Moon watched. It did not intervene. And it did not alter its course beyond the slow retreat dictated by tidal exchange. Its face remained steady in the night sky, guiding navigation, inspiring myth, marking calendars. When humans finally travelled there, stepping onto its ancient surface, they entered a museum older than any mountain on Earth. They collected stones forged in the earliest chapters of planetary history and carried them home, where laboratories examined them under microscopes and mass spectrometers. The science listened carefully. The isotopic harmony between Earth and Moon confirmed that they were born from shared mantle. Computer models refined angles of collision, suggesting a glancing blow that ejected material into orbit while merging cores. Yet mysteries remain. How thoroughly did Theia mix with Earth before debris formed? Why are isotopic signatures so nearly identical? Was there a more complex sequence of impacts? Did multiple collisions contribute? A Theia keeps some silence intact, and it offers evidence, not narrative. In its lightless craters and sunlit plains, in its regolith and deep crust, the story of a forgotten planet endures, not as myth, but as chemistry. The vanished world is not visible as a separate sphere. It is diffused through lunar rock and terrestrial mantle alike. A memory without a name, a fossil without bone. Above Earth's shifting continents and breathing oceans, the Moon continues its gradual widening orbit. It is farther now than when tides first surged across newborn shores. Its apparent size in the sky has diminished slightly over geological time. One day, far in the future, it will appear smaller still, but tonight it remains bright enough to cast shadows. It remains close enough to lift the sea. It remains ancient enough to remember what Earth has buried. The fossil in lightless stone endures, and beyond preservation lies the slow widening, the quiet drift that carries memory ever outward into space. Nothing in the cosmos stands perfectly still. Even the Moon, which seems so constant against the dark, is leaving, not in haste, not in defiance, but in increments so small that centuries pass before the change becomes visible. Each year it retreats by the width of a fingernail, a quiet widening written into the arithmetic of tides. The dance that began in fire continues in distance. When the Moon pulls on Earth's oceans, the water does not rise directly beneath it. The planet's rotation carries the tidal bulge slightly ahead of the Moon's position. This misalignment creates a forward tug on the Moon, giving it energy, lifting it into a higher orbit. In return, Earth's spin slows. A transfer, a gentle redistribution of motion. Angular momentum conserved but rearranged. The Earth turns a fraction more slowly each year. Days lengthen by milliseconds across centuries. Clocks must be adjusted, leap seconds added, to keep time aligned with rotation. These tiny corrections are modern echoes of an ancient collision. The Moon moves outward at approximately 3.8 centimeters per year. It is measurable. It is certain. Over 1 million years, that becomes 38 kilometers. Over 1 billion, 38,000. The Moon that once loomed vast above molten seas now hangs farther, its pull slightly softened, its presence still intimate but less overwhelming. Yet the tides are smaller than they once were, still strong, still shaping, but diminished from their earliest heights. The slow widening is not a severing, it is an evolution of relationship. As distance increases, the gravitational force decreases with the square of separation. Yet even at its current span of roughly 384,000 kilometers, the Moon's influence remains profound. It steadies Earth's axial tilt, it guides precession, it lifts oceans in steady breath. Their separation does not erase connection. In the far future, billions of years hence, Earth's rotation may slow enough that one side always faces the Moon, achieving mutual tidal locking. At that distant equilibrium, both bodies would show the same face to one another, frozen in a shared gaze. But long before that, the Sun will change. Stellar evolution is relentless. In roughly 5 billion years, the Sun will swell into a red giant, altering orbits, evaporating oceans, transforming the inner solar system. The Moon's retreat, steady and patient, unfolds within this larger arc of cosmic aging. Everything widens, everything cools. On geological timescales closer to the present, the widening influences climate subtly. As the Moon recedes, the length of day increases, altering atmospheric circulation patterns over immense spans. The rate of Earth's precession changes gradually, influencing long-term climate cycles known as Milankovitch cycles, rhythms of ice and warmth traced in sediment cores and ice sheets. The Moon participates in these cycles, not as conductor, but as anchor. Fossil corals preserve daily growth rings from hundreds of millions of years ago. By counting these rings, scientists infer that days were shorter then, perhaps 22 hours during the Devonian period. More days fit into a year. The Earth spun faster beneath a closer Moon. The stone keeps this arithmetic. Tidal rhythmites, layered sedimentary structures shaped by tidal cycles, record ancient patterns of rising and falling seas. In their thin laminations, the frequency of tides can be counted across deep time, revealing the gradual slowing of Earth's rotation. The widening is written in rock. It is written in coral. It is written in the orbit itself. The Moon's retreat also affects the frequency of total solar eclipses. Today, the apparent size of the Moons nearly matches that of the Sun in Earth's sky, allowing perfect eclipses where the solar disk is completely covered. This near equality is a coincidence of cosmic scale and distance. As the Moon continues to drift outward, its apparent size will shrink. In the distant future, total eclipses will no longer occur. The Moon will appear too small to fully obscure the Sun, leaving a ring of fire in the sky, a subtle loss, shift in shadow. Even now, the coincidence feels fragile, a moment in astronomical time where sizes align. It is another echo of the impact's geometry, of the angle and velocity that produced a Moon of just the right mass and distance to shape such phenomena. Nothing about this dance is static. The Earth-Moon system revolves around a shared centre of mass located within Earth's interior, but offset from its core. Together they orbit this invisible point while circling the Sun. The wobble introduced by this barycenter influences Earth's motion slightly, contributing to long-term variations in orbit. Subtle motions layered upon subtle motions, gravity weaving patterns across millennia. The Moon's retreat does not signal abandonment. It is the natural consequence of energy exchange. Tidal friction converts rotational energy into heat within Earth's oceans and crust, dissipating motion slowly while lifting the Moon outward. The heat generated by tides is small compared to Earth's internal heat from radioactive decay and residual formation energy. Yet it is measurable, part of the planet's thermal budget. The vanished world that once collided with Earth could not have foreseen this slow widening. Its mantle, now part of the Moon, participates in a process that extends far beyond the moment of impact. Distance grows, but memory persists. But when human instruments measure the Moon's drift with lasers reflected from its surface, they are tracking the afterglow of a collision billions of years old. Each centimetre gained is a continuation of that first transfer of angular momentum. The Moon was born close. It will not remain so forever. Yet even as it retreats, it remains bound. Gravity stretches between them like an invisible thread, thinning but unbroken. One day, perhaps, the system will reach equilibrium. Or perhaps solar evolution will interrupt the dance before that point. The future is long, but not infinite. For now, the Moon rises and sets as it has for eons, slightly farther each year, slightly smaller in the sky than in ages past. The sea still lifts, the earth still turns. The widening continues in silence, and in that widening there is a quiet melancholy, not of loss, but of time passing in increments too small to feel yet too large to deny. But what remains when distance grows, or when memory drifts outward into deeper night? Distance is not absence, it is a softening. The moon's retreat does not break the bond, it stretches it. The gravitational thread between Earth and its companion grows longer, thinner perhaps, yet still intact. The tides still rise, the axis still steadies, the rhythm continues, though altered by the slow arithmetic of separation. Each night the moon appears nearly the same as it did centuries ago. Its phases wax and wane in familiar cadence. But fullness becomes shadow, shadow becomes crescent. Crescent dissolves into darkness, then light returns, yet beneath this repetition the geometry shifts, the moon's orbit lengthens imperceptibly. Its orbital period increases by tiny fractions. Earth's rotation slows by milliseconds per century. The system adjusts like an old clock redistributing weight along its gears. Stone keeps count. Ancient tidal rhythmites preserved in sedimentary rock from the Precambrian era that reveal patterns of daily and monthly cycles etched into layers. By measuring the thickness and repetition of these laminae, it becomes clear that days were once shorter, months once briefer. More days fit within a year when the moon was nearer. Time itself has stretched. Coral fossils echo the same story. Growth bands, daily and annual, record rotational history. In Devonian corals, roughly 400 million years old, there were about 400 days in a year. Earth spun faster then, though completing more rotations in the same orbital period and around the sun. The moon was closer, the sea rose more often, the dance was quicker. As the moon retreats, tidal friction diminishes gradually. The bulges raised in Earth's oceans are slightly smaller than in ages past. Energy transfer continues, but the rate of widening will decrease over deep time as distance increases. This is the mathematics of gravity. Force declines with the square of separation. The farther apart the bodies move, the weaker the pull, the slower the exchange. Yet even weakened, the influence remains vast compared to other celestial bodies. The sun exerts tidal forces on Earth as well, but the moon's proximity gives it dominance in shaping the oceans. Without the moon, solar tides alone would be weaker, less dynamic. The sea would breathe more faintly. In the distant future, perhaps billions of years hence, Earth's day may lengthen to dozens of current hours. The moon's orbital period will increase accordingly. The system trends toward a distant equilibrium where rotational and orbital periods synchronize. But long before that quiet endpoint, other forces intervene. The sun's gradual brightening will alter Earth's climate profoundly over the next billion years. Increased solar luminosity may trigger a runaway greenhouse effect, evaporating oceans and sterilizing the surface long before tidal locking occurs. The moon's retreat unfolds within this larger arc of stellar aging. Everything is nested in larger cycles. Even now, the coincidence that allows total solar eclipses exists only because of current distances. The moon's apparent diameter in the sky nearly matches that of the sun, a rare alignment of scale and separation. This coincidence will not last. As the moon continues outward, total eclipses will cease. Annular eclipses, rings of fire, will become the norm. Shadow will change shape. The humans who have witnessed total eclipses with awe and fear live in a narrow window of astronomical geometry. Before and after this era, the sky would tell a different story. The widening touches perception as well as physics. Yet in its retreat, the moon does not diminish entirely. Its gravitational stabilization of Earth's tilt persists across vast spans. Numerical simulations suggest that without a large moon, Earth's obliquity might vary chaotically between near zero and extreme angles over millions of years, dramatically altering climate. The moon's mass damps these variations, maintaining tilt within a relatively narrow band. Stability is not stillness, it is constrained change. This constraint has shaped Earth's biological evolution. Ice ages have come and gone, but within limits that allowed recovery. Life adapted within oscillations rather than being erased by extremes. The vanished world's legacy is woven into this moderation. In the quiet widening, there is something almost tender, a release that does not abandon, departure that continues to care from greater distance. Laser ranging experiments confirm the retreat with exquisite precision. Beams sent from Earth bounce off retroreflectors placed on the lunar surface, returning fractions of a second later. The time delay reveals distance with millimeter accuracy. Their science listens to the silence between pulses of light. Each measurement is a reminder the moon is leaving, slowly, inexorably, guided by the same physical laws that bound it here. Yet even as it drifts, its light remains constant to human eyes. Its phases guide calendars. Its gravity stirs oceans. Its presence anchors myth and science alike. The widening is not visible in a lifetime. It is visible in stone, in coral, in sediment, in the slow recalibration of clocks. One day, billions of years hence, Earth and Moon may face one another in synchronous stillness, each presenting the same hemisphere in eternal gaze. But that day lies beyond the horizon of current life, beyond the span of oceans as they exist now. For now, the Moon continues its outward journey, carrying within it the memory of collision, the isotopic signature of a vanished planet, the scars of ancient bombardment. Distance grows, memory endures, and in the widening silence between them, a final reflection waits, not of loss, but of what remains when time has stretched its thread to its thinnest light. What if Earth once knew something and forgot? The question lingers like dust in a shaft of light. It does not demand an answer. It settles instead, slowly, the way ash settles after fire has passed. High above the breathing oceans and drifting continents, the Moon hangs in patient orbit. It is farther now than when it first rose above molten seas. It is smaller in the sky than in the age of coral and shorter days, yet still near enough to lift the tides, still present enough to steady the tilt of a planet. It is a memory made visible. The world that touched and vanished has no name carved into stone, no separate orbit, no independent light. Its iron beats within Earth's core, its mantle circles overhead in pale silence, its identity dissolved in heat and motion, braided into a new form that neither world could have become alone. And nothing of it was wasted. The collision that might be called destruction became architecture. The glancing blow that tore mantle from mantle became balance. From that moment of incandescent fracture came longer days, tempered seasons, tidal rhythms that stirred the earliest chemistry of life. The Moon does not speak of this. It does not remind. It simply reflects sunlight across the dark half of Earth each night, a quiet echo of ancient fire. Earth has forgotten much. And its surface has been rewritten countless times. Mountains have risen and eroded, oceans have opened and closed, species have bloomed and vanished, leaving fossils pressed into rock that will itself one day be subducted and melted. Memory here is temporary, it folds inward. The Moon remembers differently. Its craters remain where they were struck billions of years ago. Its basalt plains hold the stillness of ancient lava. And its regolith preserves footprints and micrometeorite scars without judgment or revision. It does not recycle its past, it keeps it. In laboratories, isotopes whisper their ratios. Oxygen aligns with oxygen. Titanium echoes Earth's mantle. Tungsten marks the timing of core formation. Science listens and reconstructs the silent event. A Mars-sized world, a glancing impact, a ring of molten debris learning to orbit. Yet even with equations and models, something remains beyond complete articulation, because this story is not only about mechanics, it is about transformation. Two bodies met, one vanished as itself, both continued as something new. Gravity does not choose. It binds, it pulls matter into relation, and in that relation, new forms emerge. The Earth-Moon system is not an accident in isolation. It is a natural outcome of early solar turbulence. Yet within its inevitability lies an elegance difficult to ignore. As the Moon steadies Earth's lean, it slows Earth's spin, it lifts the sea in steady breath. It marks time in phases that wax and wane, teaching even human sleep to follow its cadence. And still it drifts outward, centimetre by centimetre, a slow widening that will continue long after present concerns have dissolved into sediment. Distance does not erase origin. The vanished world lives on not as a separate sphere but as influence. Its substance shapes climate cycles. And its iron strengthens magnetic shielding, and its mantle reflects sunlight back to night. In the fossil record of Earth, extinction mark abrupt endings. Yet above each ending the Moon remained. When forests burned under asteroid impact, when volcanic winters darkened skies, when ice advanced across continents, the Moon continued its orbit, steady as breath. Some truths are not loud, they are persistent. The memory that remains is not carved into a monument, it is written in rotation and tide. And it is written in the length of day, in the stability of seasons, in the coincidence that allows a perfect solar eclipse in this fleeting era. The moon's presence has shaped more than coastlines, it has shaped possibility. Had the collision not occurred, had the angle been different, the velocity altered, the masses mismatched, Earth might spin too quickly. Its tilt might wander wildly, its climate might lurch between extremes beyond recovery. Instead, balance emerged from violence, and harmony from fracture. This is not a moral, it is a pattern. Across the cosmos, collisions build as often as they destroy. Galaxies merge, stars are born from compressed clouds, planets form from accreted dust. The moon is one such creation, ash that learned to orbit, memory that learned to shine, and as it drifts farther into darkness, it carries the fossil of a forgotten planet with it. Not as a relic to mourn, but as a foundation upon which rhythm was built. The sea still listens, yet the earth still turns, the moon still rises, and somewhere in the chemistry of stone and water, the echo of that ancient touch remains, not as loss, but as continuity. What if Earth once knew something, and forgot? Perhaps it did not forget entirely. Perhaps it had placed the memory in orbit, where it could not be buried. And each night, when the pale companion lifts above the horizon, the planet remembers without words, a silent agreement between stone and light. And a story that began in fire and continues in drift. The story does not end, it thins, like mist at dawn, like breath fading into colder air. It becomes quieter without disappearing. The moon continues its patient arc, and the earth continues to turn beneath it, and between them stretches a history too vast for a single word like beginning or end. In the long future, continents will rearrange again, oceans will narrow and widen, mountain ranges will rise where seas once lay. The carbon in forests will return to stone, then to air, then to stone again. Ice will come and go in cycles measured not in seasons, but in ages. Through all of it, the moon will remain, smaller in the sky than it once was, yet constant enough to be familiar. Its phases will still mark time, its gravity will still tug at the sea, its pale face will still hold the dark plains of ancient lava and the bright highlands of primordial crust, but the widening will continue. When centimetre by centimetre, millisecond by millisecond, the Earth's spin will ease further. Days will lengthen beyond the 24 hours known now. Tides will soften slightly more. Total eclipses will become memory, replaced by rings of sunlight encircling a smaller lunar disk. Geometry will shift, shadow will change, yet the origin will remain embedded in stone. Deep within Earth's core, an iron that once belonged to a vanished world helps generate the magnetic field that shields atmosphere from solar wind. Without that field, lighter gases might have been stripped away over eons, leaving the surface barren. Within lunar rock, oxygen isotopes preserve the signature of shared mantle. Without that shared chemistry, theories would fracture differently. Science would tell another story. The collision is not visible now. There is no scar in the sky marking where two worlds once met. There is only orbit and tide and the steady transfer of energy between them. Memory in this system is structural. It is written into mechanics. And when distant generations look upward, whether human or something beyond human, they will see the same pale companion and perhaps wonder at its origin. Instruments may grow more precise, models more refined, yet the essential truth will remain simple: two worlds touched, one dissolved, both endured. The vanished planet did not disappear into emptiness, it became relationship, it became balance, it became the quiet sculptor of seas and the keeper of early scars. There is something almost tender in that transformation. Violence did not yield void. It yielded continuity. Across the solar system, other moons circle other planets, some captured, some co-formed, some shaped by tidal forces into geological restlessness. But Earth's moon is singular in its proportion, in its influence, in its intimacy. It is large relative to its planet, close enough to steady, far enough to shine gently. Its existence feels inevitable in hindsight, yet it balanced upon precise angles and velocities billions of years ago. A slightly different collision, and no moon might circle here now. Chance and necessity braided together. In the vast darkness beyond, stars are born and die. Galaxies collide in slow-motion spirals. Black holes merge, sending ripples through space-time itself. And compared to such events, a planetary collision is small, yet here, on this particular world, it shaped everything. The moon's light has guided migrations, it has inspired calendars carved into bone, it has been mistaken for deity and for mirror, it has marked the passage of months long before months had names, and beneath its steady gaze, life unfolded. From single cells to forests, from forests to minds capable of looking back and asking how it all began, the answer is not loud. And it is layered. It is found in the isotopic harmony between Earth and Moon, in the slowed rotation of days, in the stability of tilt, in the preserved craters that mirror a history Earth has erased. The Moon is a fossil of fire, a memory of fracture, a companion born from loss, and as it drifts farther each year, it does not diminish the story, it extends it. The widening is part of the narrative, a reminder that even bonds forged in cataclysm evolve over time. One day, billions of years hence, the sun will swell, oceans may boil away, the moon's orbit will change under altered gravity, the system will not remain as it is forever. Nothing does. But tonight the moon still rises, the sea still answers, the earth still turns beneath a steady tilt. What if Earth once knew something and forgot? Perhaps it remembers in motion rather than in words. Perhaps it remembers in the length of its day, in the rise of its tides, as in the pale light what softens its night. Perhaps the memory was never meant to be held in thought. Perhaps it was meant to be held in orbit, and so the moon drifts on, carrying within its stone the quiet truth of a world that touched and vanished, a truth that does not shout, does not conclude, but lingers like dust suspended in starlight. The stars above continue their distant burning, the tides below continue their patient breath, and between them a pale fossil circles. Her whispering without sound, time does not pass, it settles.